synthesis and evaluation of shell calcium carbonate calcium oxide materials derived from Corbicula flaminia for fluoride adsorption in aqueous solution. Introduction. Fluorine is the most electronegative of all elements and occurs primarily as a negatively charged ion in water, the fluoride ion. Many methods have been used to remove fluoride from drinking water, such as ion exchange columns, coagulation, membrane filtration, and electrochemical methods. However, the high costs of these technologies make their implementation impractical for developing countries, where high concentrations of fluoride are commonly found in water. Calcium-rich biomasses are among the options for removing contaminants. One of the main advantages of these materials is that they can be obtained from natural, low-cost sources such as eggshells, animal bones, and the shells of oysters and other mollusks, which significantly reduces production costs compared to commercial analytical-grade reagents. In this context, the Asian clam, Corbicula flaminia, represents a potential source of calcium carbonate due to the high concentration of this compound in its shells. This species, native to Southeast Asia, was accidentally introduced into various freshwater bodies in the Americas, where it has established itself as a widely distributed invasive species. Its presence can cause adverse ecological effects such as the displacement of native species, the disruption of food chains, and changes in the physico-chemical conditions of the ecosystems it inhabits. Therefore, the use of this clam as a raw material not only represents an economical and sustainable alternative for obtaining calcium-rich materials, but also contributes to the valorization of residual biomass associated with the management and control of this invasive species. The objective of this study was to prepare materials from Asian clam biomass and evaluate their ability to remove fluoride. In addition, the resulting materials were characterized to determine their morphological properties and the functional groups present on their surfaces. Methodology. The clams were collected from the Paraiso seawall located in Catazaja Lagoon, Chiapas, using manual collection and trawl nets. Once collected, the shells were washed with running water to remove sediments and particles adhering to their surface. They were then boiled in water for 2 hours to remove any remaining organic matter, rinsed with deionized water, and dried in an oven at 150 degrees Celsius for 12 hours. Once dry, the shells were ground, and the resulting material was sieved to a particle size corresponding to mesh sizes 20 to 60. Of this material, 50 grams were retained without additional heat treatment and designated as natural shell, while the remaining 400 g were calcined in a muffle furnace. To obtain calcium carbonate, the material was calcined at 600 degrees Celsius, while to obtain calcium oxide, calcination was performed at 800 degrees Celsius. The removal tests were conducted using fluoride solutions with concentrations ranging from 6 to 30 milligrams per liter. For each experiment, 40 milliliters of solution and 0.05 grams of material were placed in centrifuge tubes. The systems were kept in contact for 7 days. At the end of this period, the residual fluoride concentration in each solution was determined using an ion-selective electrode. Based on the initial and final concentrations, the percentage of fluoride removal was calculated for each material. The materials, concha, calcium carbonate, and calcium oxide, were characterized using scanning electron microscopy and Fourier transform infrared spectroscopy to analyze their morphological characteristics and the functional groups present on their surfaces. Additionally, a thermogravimetric analysis was performed. Results. The material with the highest percentage of fluoride removal was calcium oxide at 34.3% with a maximum adsorption capacity of 2.59 milligrams per gram. Microscopic images revealed that the shell has a relatively smooth surface with low roughness. In contrast, the calcium carbonate and calcium oxide materials exhibit progressively rougher and more heterogeneous surfaces. These morphological changes can be attributed to the heat treatment used during their preparation, carried out at 600 and 800 degrees Celsius for calcium carbonate and calcium oxide, respectively. An increase in the calcination temperature may promote changes in the structure and surface morphology of the materials. In the spectra of the materials, the characteristic bands of the carbonate ion, typical of the calcite phase present in the clamshell, are observed. The most intense and broad band in the spectrum, located in the region near 1400, corresponds to the asymmetric stretching mode of the carbon-oxygen bond and appears with high intensity in the calcium oxide material. In the region from 900 to 700, 2 narrow bands are distinguishable, assigned to out-of-plane and in-plane bending of the carbonate, respectively. Additionally, a weak band is observed before the main band, corresponding to a combination band between the symmetric stretching mode and the in-plane bending mode. In the thermogravimetric analysis of the materials obtained from the shell of the Asian clam, a major thermal event was identified around 688 degrees Celsius, associated with a mass loss of approximately 40%. This behavior corresponds to the thermal decomposition of calcium carbonate to form calcium oxide, with the release of carbon dioxide. This process represents the main thermal transformation of the mineral phase present in the material. Conclusions. The chow obtained from the shells of the invasive clam species Corbicula flaminia proved to be an effective adsorbent for the removal of fluoride from aqueous solutions. FTIR and TGA analyses confirmed the purity and thermal stability of the material, while micrographs revealed the morphology and porosity of the samples. This application not only offers an environmentally friendly alternative for treating contaminated water, but also proposes a management strategy to mitigate the environmental impact of this invasive species in Mexico's watersheds.